So coming back to a slightly more in-depth look at the digital building platform and its data stacks and internal layers, you can see that the digital building platform is more than just a data collector and organizer. It's an AI system enabler in its own right. It's designed to produce next generation control, as we call it, and that's control based on learning and models. So what you can see on the right are the internal layers, and we can just run through those quickly. At the bottom, there's the data pool management, and that's really just dealing with the huge amounts of time series data you get from buildings. That's just managing the data flow, making sure that if anything happens, it'll stay robustly connected, keeping the security and so on. Above that layer, then you have the data integrity, where it's analyzing the data, checking for issues, reporting any issues it does find, and the correction, where it can either fix itself or it can make a call back and say, look, I'm missing this data, let's fill that in. And this all happens seamlessly in the background. This is not user operated. Now, depending on the type of actions you need further up the chain, you might want to filter your data, and that will take away the noise that's generated from all sensor data. And you may have dropouts, and it will just predict over those as well, and give you nice, clean, smooth data from which your AI and MLs can learn from. But sometimes you can't do that, and sometimes raw data is better. So that's why you have the two blocks there. Now, the block above that is external non-building data, and really that's just external factors that will affect the building. And that could be anything from outside pollution measurement to public transport to footfall somewhere else in the city. It can be anything. If it has an impact on what we're learning and we have a data feed, we'll use it. And you'll see the correlations deep in the data anyway. So the layer above that then is the learning layer. It's the bit that extracts the value from the patterns and the data that you've got. The layer, the machine learning, the AI, and we've only put them two there, but actually that's broken down into many, many subsets. You've got many different types of artificial intelligence and different ways to learn and different mathematical approaches as well. So above that, you have the command and control, which is really driven from the decision cost function. But it can be driven from every layer depending on what rules you want. The decision cost function takes the learning from across all of the strands within the building. So you'll have many different elements, many different silos, many different parts of the building where you've learned data. You've learned ways of optimizing it. But quite often you can't apply them all at the same time. There'll be interactions. So the decision cost function is looking at those interactions and it's saying, well, if my goal today is to have the best quality air in the building, then I'll have to sacrifice a little bit of energy efficiency to maintain better air quality, for example. And it's continuously running through its decisions, making the best use of the information that it's got in terms of what it's learned. And remember, all of this data is being applied with the knowledge of the building physics, which has been learned as well. A key element that we found is learning is important, but it's as important as forgetting. So it's continually learning, but it's also continually forgetting. And having that method of learning means that if the business or the building use case changes, the learning algorithms will adapt. So you don't just set it up one day and it stays and it goes, well, that's what's going to happen every other day. As the business or the building is used differently, it will continually adapt. And you need that because you have different weather patterns, different seasons, and different use cases. So it will be able to detect that there'll be a little bit of lag in between while it's kind of reaffirming its learned patterns. But if you have a party every Tuesday, it will learn within a week that that's happening, and then it will reinforce that over the next 2 or 3 weeks. And that's important. As I say, forgetting is just as important as learning if you want to keep a dynamic system. So now we're going to move on and take a look at some demos, a quick a web presentation of the digital building platform where you'll see the points coming in and some charting, and we'll show you some of the dashboarding as well that links from a satellite service.